Will the Southern Hemi swell pattern continue? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Monday, May 26th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you have a comment or question, write it up down below. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Clay Goose, Our Predicament, Evolution Moto, Tim Caston, Peter Carpenter, and special call out to Jake Marlowe for the big contribution for the week. I appreciate all of them very much, and I appreciate you for joining and hanging with us for this next hour. With that, let's get to work. We'll start by looking at significant wave heights around the planet. Starting in the North Pacific, there's actually a little gale up there with maybe 17, 18-foot seas, and maybe some little background swell will result for the North Shore of Oahu, but nothing significant. Remnants of a broader gale in the South Pacific with still 28-foot seas. This is basically traversed while pushing northeast the whole way across the South Pacific. Swell from this is radiating north and is going to be impacting anywhere from South America the whole way up into the Pacific Northwest and beyond, so that's good news. In the North Atlantic, relatively calm pattern. Same deal for the South Atlantic, except under South Africa. Gale with 22-foot seas is producing some, I'll call it 13-second period swell radiating towards the coast there. Then finally over in the Indian Ocean, pretty good gale there with 34.8-foot seas right there. That's the highest seas over this entire domain. And most of at least the significant wave model charts have that feature, with winds 39 knots, peak winds over the entire domain as well. And then a secondary gale with about 27-foot seas. So the pattern definitely has shifted to the south, as would be expected for this time of year. But before we get into the forecast, we're going to start by looking at current conditions. We're going to start up in the Pacific Northwest, Grays Harbor, using the buoys, number 036. That's there off the Columbia River. We're looking at all the energy that's hitting that buoy all the way up from 33.3 second period energy, which there is 0.0 feet of energy, not unexpectedly, the whole way down to 5 second period, just pure wind chop. And there's a little bit. We see most of the energy here in the 9 to 11 second period range. That would be wind swell. And then, but there is pieces of energy in the 18 to 14 second period range. And best guess is that's probably Southern Hemi swell. So let's go take a look, see how the algorithm does sorting out which swell is which. Primary swell, that is the swell that would produce the largest surf, 4.1 feet at 10.2 seconds from the west, 277 degrees, theoretically making surf 4.2 feet. That'd be at your standard beach break. Top reef breaks could be up to double that size. And then secondary swell, well, there is none, so it's all really just that wind swell. Heading south into Northern California, we go down to the Point Reyes buoy, number 029, just north of Ocean Beach, San Francisco. Same deal here, a lot of wind swell, but also a fair amount of mixed Southern Hemi swells, all overlaying on top of one another. Primary swell, 4.2 feet, 8.8 seconds. That is, again, the wind swell from 298 degrees, so northwest. Surf heights, 3.7 feet. But then we have the secondary swell, 2.2 feet at 15.8 seconds from 195 degrees, making surf theoretically at 3.4 feet, but it was definitely head high, maybe a bit overhead on the biggest sets on the peak at top spots in Northern California. That was earlier today. I'm going to go down to Southern California, just off of San Diego there, the Point Loma South buoy, buoy number 191. And you see the wind swell definitely attenuated by the Channel Islands. Southern Hemi swell, though, still looking strong. 14-second period, the primary energy, but stretching the whole way out to 25 seconds. Not that it's rideable, that's just, kind of a component of the other swells. Primary swell, 2.7 feet, 14.6 seconds from 194 degrees, making surf at 3.9 feet. But again, is probably, head high to maybe a little bit overhead, top spot, something like that. And then the secondary swell, now here it picked up because the wind swell wasn't kind of polluting everything. 1.3 feet at 18 seconds from 201 degrees. So that adds another 2.3 feet, not on top, but in the mix, if you will. And then finally, to the south shore of the Hawaiian Islands, we're using Lanai because it's more protected from the wind swell and any northwest swell. Buoy number 239. We see just a little tiny blip of energy here in the 14-second period range. Primary swell, 1.1 feet at 13.7 seconds from 184 degrees, making surf at about 1.5 feet. And then some other random swell, 1 feet at 10 seconds from 181 degrees due south, or 1 foot surf. So let's do a quick rewind going back a week. We're going to start in the North Pacific, 18Z on Sunday, the 18th of May. That's when we did our last video. Yeah, there was a gale with 21-foot seas there off the Pacific Northwest. That is long gone, swell from it gone. And then just rolling this out pretty much as fast as we can go. Yeah, 28-foot seas off of Kamchatka. This is on Friday, the 23rd of May. Most of all that aimed pretty well to the north. Oh, a little bit of 30-foot seas. Now, I saw this on the models, didn't believe for a second what had happened, but apparently there is still enough little energy, winter-type energy in the atmosphere to get something going. And then here we are at current time. Oh, no, we're not Sunday. We're into Monday now. We missed a day here. And there we are, 18Z Monday, the 26th, and not a whole lot going on. Down to the southern Hemi, the ice anomaly. It's not an anomaly for, as best we can tell. This is legitimate. Now, I think the density of these pieces of ice here, I mean, this looks like just some massive iceberg, but I bet you if we zoomed in really close, we'd find out this is more like chunks of ice, not a solid piece of it. Again, I'd love to be able to get a little bit more zoomed in kind of view of what's really going on from a satellite or something, but no luck so far. Anyway, so 18Z on the 18th of May. Here we go. We had a gale here in the far southeast Pacific. That was on Tuesday with 40-foot seas. Did it get any more? Nope. And then it pushed, and let's see how much of this was really in the Southern California swell window. So that for sure was on Tuesday, the 20th of May, in the window. About 117, 118 west is the cutoff for like San Diego, that area. And this was just barely in the swell window. Super south angle, though, mainly for Southern California. And the reality is this mainly affected Chile, Peru, South America, that area. Not so much a swell producer for California. And you can see the swell front from this, and it was pushing in. I think it was on Friday and Saturday. And good size swell for sure, but nothing over the top. So we're into Friday now. There's a bit of a pause here. And then on Saturday, we had a little gale that started to blow up here with 30-foot seas into 18Z Saturday, lifting northeast, 31.5-foot seas, 32-foot seas this morning. Oh, that was Sunday. Again, I keep thinking it's Sunday, but no, it's Monday. And you see it pushing its way across, there we go, across the South Pacific. So swell from this definitely pushing to the north, bound for Hawaii, sideband energy, probably more direct for California, and certainly for Peru, Chile, Central America, up into Mexico. The North Atlantic, we'll roll this through. You can sort of see for yourself what is or isn't going on. Nothing too noticeable, not surprising given the time of year. 18-foot seas off of Greenland, that's about it, I believe. But you see, impacting Ireland on Sunday into probably Monday, and then that's it. The South Atlantic over the past week, yes, this little system down here in the far south, but really kind of focused on Africa now, or South Africa. 30-foot seas on Wednesday, building to 35 feet. sweeping pretty much off to the east, but you can see there was swell that was radiating up the coast there. That swell has come and gone. Another system as of early Saturday had 33-foot seas. And yet another behind that, let's see, we're on Sunday, that's 39-foot seas, 40 feet, but sort of falling southeast. Sideband still likely radiating up towards South Africa, but, you know, pretty much very limited sideband swell would be my guess just by looking at the chart. And then the Indian Ocean. There was this storm with 42-foot seas that built on, this was on Sunday, so this was a week ago, built more, and I think right there, 54.3-foot seas. So a couple of our viewers were quick to pick up that storm with 54-foot seas is on the Great Circle path into Southern California. This is kind of like chasing unicorns. I've done this a few times where you get some, you know, the Great Circle path we're going to look at in a minute. We're going to do is sort of a deep dive analysis, but the short to say, theoretically, a storm here with seas actually aimed to the southeast could theoretically produce swell pushing up into the Pacific the whole way up into Southern California. The question is, will this one actually do that? And that's going to be part of another little small section we're going to do here in a bit. But anyway, that system pushed off, faded, certainly has produced swell. You can see the leading edge of it. Well, that swell's already come and gone relative to South Australia, and the gale all but gone. Then looking further into Thursday, Friday, Saturday, the 24th, nice little gale here with 36-foot seas aimed directly at Southern Australia, pushing right to it. In fact, it's already, let's see, there we go. We're into Monday. Already come and gone. Probably pretty much of a big raw swell for South Australia, but more developing behind that. So a pretty active pattern for the Indian Ocean, sort of from a point south of Africa into the Indian Ocean and then feeding into the southwest and south central Pacific. Not too bad. So we're going to do a quick discussion here about Great Circle paths. What are they? Well, effectively, it's like trying to draw a straight line on a globe. You see a map, and it distorts the reality of the Earth's surface because the map, like a chart like here, is all flat. But the Earth's surface is a sphere, a globe. So a straight line on a sphere, and then you project that onto a flat surface, isn't a straight line. And as you can clearly see here, these are the actual paths from, we're picking somewhere in Southern California here, out across the South Pacific Ocean, and their angle, 191 or 161, 175 degrees. New Zealand, of course, creates a shadow from 222 up to 231 degrees, and then there's this tiny little window between Tasmania and the tip of New Zealand, about a 2-degree window. You can maybe sneak something in there. Then, of course, there's Tahiti here. So that's, and these white lines here, these are 600 nautical mile distances from Southern California. So as you see, the further you progress out, the longer the distance is. Most of our swell comes from down in this area without really counting all this, it's about 5,500 to 6,000 nautical miles. And if you follow those Great Circle paths to their logical extreme, you end up over on the halfway around the other side of the planet in the Indian Ocean. Now notice, somewhere down around in here was where that storm was last week. Let's go look at the chart again. Here it is, 54 feet at 51.5 south, 87.2 east, right there. So keep those numbers in your mind. So then I put the position, the latitude, this is relative to Southern California, down roughly around Dana Point. And then the position of the storm, 51.5 south, 87.25 east. Okay, and the date and the time and the max sea heights. And what this tells you is the bearing, 217.54 degrees. That is the great circle path from the center of that storm to Dana Point. All right, so let's do a look-see. 217.35 degrees. 217 degrees. So there's 218 or there's 213. The center of the storm was over here somewhere on the 217 degree path. So you can clearly see, and the fetch and the seas were all aimed to the southeast. So there is a path, if you follow it right here, right on up, right into Southern California. Now, does that mean that some massive long period swell is coming into Southern California? Well, for one, it's an extremely long distance here. In fact, let's go look at the distance. 9,272 nautical miles. So that's almost, like 1 3/4 times the distance our normal southern hemi swell has or has to travel to get to Southern California. And even at that, it's like one set every 20 minutes. So on a 9,000 nautical mile distance, you're probably talking one set every 40 minutes, maybe every 35 minutes, something like that. Where am I going with this? Well, the debate is, and we talked about some in the comment section last week, will there actually be swell from this system? And is it going to reach Southern California? And if so, how big will it be? And if it's there, will you even be able to know it's there? So we're sort of teasing that out. All right. Now let's do one other thing before we get into answering the question directly. The great circle path was 217 1/4. All right. So there's Tahiti. I think it's Bora Bora up here. There's 216. There's 218. So there is literally a clear gap between the islands. And here's what they call the cheese grater. All the French Polynesia, the atolls, these are all dry atolls right in here between about 209 and 216 degrees. And there's more atolls over here, but not so bad. Swell can probably get through those. But it's a pretty hard push to guess if anything will get through. Let's do a closer examination of right there. So Google Earth here. Here's French Polynesia right here, Tahiti proper. Then here's Bora Bora and the islands right there. The gap is literally between here. Okay, and let's see if we can go up. You can see, and it's clear up here. Here's the cheese grater, as it's called. You can see, and I know you can't see it here, but if you have Google Earth and you push your hand or whatever your icon is over here down the lower right-hand corner, it'll tell you the actual depth of the water here, and all this is zero. Maybe we can even zoom in here. Yeah, here we go. You can't really see it, but that's reef and breaking waves and just, so that is a hard no-go. But there is the tiniest gap here. And then once you're north of Bora Bora and Mapiti, there is a path in there. And I know you can't see it, but right in there, that's Tahiti, that's Bora Bora. So between 217 and about 218 or so, once you get north of there, up to 222, that's free and clear, and that path does go into Southern California as well. So theoretically, it's possible, but one, there is distance, just an extreme distance. Two, there is just the thinnest of window right in between there. And three, the swell, as it radiates away from the source, which is probably over here, it spreads out north and south too. So, it's got to get through that tiny little window, and then it's still got to make the probably, 3,000 or 4,000 nautical mile journey on into Southern California. So it theoretically should be pretty well dissipated. But let's do the math just for fun. Here's the swell calculator on Stormsurf. You can dig around here. Maybe I can even show you over here. Over on the left-hand side, swell calculator, you click that, you get this little thing. You got to plug in your coordinates and the coordinates of the storm, and then it'll give you the distance away from you. It'll give you the swell direction. You put your sea heights in here, and then it does a very rough calculation of what the ending swell height will be. 3.7 feet at 25 seconds. Now, that's not for real because this is based on like a very solid fetch area. This one, the 54-foot seas was not that high, so you probably want to chop between 50 to 75%, or reduce this by a quarter to almost half to get a swell height. But theoretically, and this storm was big enough to produce a 25-second period swell, starting on, and this is on GMT, so Thursday 3Z, that's really like Wednesday at 8 o'clock at night. Then 22-second energy on Friday, May 30th at about 5 a.m. and 20-second energy into Saturday morning, roughly May 31st at 7 or 8 a.m., something like that. So theoretically, it's possible, if there isn't any other swell hitting, if all the stars align, and if the swell doesn't decay to nothing before it gets here. So, and one more thing. So on stormsurf.com, if you go to the Pacific forecast, which is right here, this is where we write up all the details of every swell that's in the water. I mean, just, ridiculous amounts of detail, but basically every 12 hours where the storm is, what the winds are, what coordinates were the seas at, how high were the seas, and when will the swell arrive. And down here, the strong Indian Ocean storm. We did it for fun for Southern California. Swell arrival period where 25 seconds would be Wednesday starting about 7 p.m. 22 seconds would hit on Friday, 4 p.m. Period would drop to 20 seconds on Saturday, the 31st at 9 a.m. And you get it. Swell size theoretically 3.85 feet. But with the decay charts and near 10,000 mile distance, you get the idea. Odds of seeing anything, and assuming there's no other swell in the water. But what you would look for is you would go to the Point Loma buoy, or whatever the buoy is of your choice in Southern California. The seated buoys are the best. They're way more sensitive. And you would start looking on here and go out into this area and see if there was a bump of something, and see if and this would be like Wednesday night, Thursday, Friday, Saturday, and just see if there's anything that even remotely looks like it might fit the bill. I'd say the odds of that happening are pretty much near nothing. But it's a fun little science experiment and a little brain tease to see oceanography in action in the real world. Right, with that, let's go see what's coming for the future. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales when those gales form, help direct their track. We're looking for a trough, a push in the jet to the north. There we go, right there. What that helps do is create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, gets traction on the ocean surface, generating winds. Those winds help generate seas and impart energy to the ocean. Those seas, as they radiate away from the fetch area, the lesser period elements decay off, exposing the long period swell, just like what we were talking about. And of course, pure swell with longer period, once it hits your beach, produces surf. All right, so we have a trough here in the far southeast Pacific, capable of generating some sort of a gale. And then we have maybe the weakest of troughs south of New Zealand. But otherwise, when the jet's pushing due south into Antarctica like there, that's a ridge that supports high pressure. That's not good for storm production. Let's put this into motion and see. As we get into Tuesday, the trough pretty much moves out of the Southern California swell window, 117 west, right about there. That'd be San Diego. We get into a zonal flow. The winds are just pushing west to east. Doesn't really do anything for supporting trough development. Now we're into Thursday the 29th, and here we go. Another trough starts building in the southeast Pacific. This would be Thursday the 29th of May, and another trough starts building under New Zealand. This is the one I'm probably more interested in. You see it push clearly under New Zealand, being supported by 140 knot winds. This other trough here, yeah, most of the axis, the furthest north axis of it is already east of the Southern California swell window. So this is our main trough. Look at that big ridge crashing into Antarctica on Saturday, the 31st of May. And then the New Zealand trough, the winds really die off as we get into Sunday, the 1st of June, and it fades out. We're now out, a week out, back to the zonal flow. And Yes, the models do go out 2 weeks. Why don't I show it? Because it's never believable, even hardly a week out. It's just a fantasy, and I don't like being teased. Surface level pressure and surface level winds. So here we go. Yes, we know there's a trough here. There's low pressure, 35 knot winds. There are 45 knot winds, but they're all aimed at Antarctica, so that does nothing. A little bit of a gale trying to develop under New Zealand. As we get into Tuesday, yeah, nothing really serious going on. 30 to 35 knot winds. You need a broader area of 45 knot winds. Notice there, let's go back here. Tasman Sea, those of you that are interested in Fiji, right up around there, this is definitely capable of producing swell for Fiji and, of course, up along Australia, New Zealand, all that kind of area. But relative to our main forecast area, nothing. But then we get into Thursday, 29th of May. Another gale starts building south of the Tasman Sea, 40 knot winds, a little area, 45 knot winds. And that gets better exposed east of New Zealand as we get into Friday, the 30th of May, and then Saturday. Still only 30 to 35 knot winds. I really wish it was 45 knot winds, but over a pretty broad area. So that, at this point, is more something that just bears watching. There we go, 40 to 45 knot winds on Sunday night. That looks better, 50 knot winds. But again, now we're almost a week out. We'll believe it when it happens. But this all sort of suggests what the title is talking about. There's a continued series of gales, none of them over the top, but none of them, you know, at least there's something, and it seems like we're just in this flow of steady southern hemi swell, so can't really argue with that. And this also has the capability, a lot of this stuff has been the Southeast Pacific, focused on California, bypassing Hawaii. This looks better for the Hawaiian Islands as well. All right, so this is residual gale energy, 28, 29-foot seas from a gale that pushed under New Zealand, traversed across the South Pacific. Swell from that is pushing north as we speak, bound into California about a week from now. Looking forward, what's going to happen? Well, we know not a whole lot for a bit. There's kind of a break. Then we're looking over here, Tasman Sea area in New Zealand. There we go, 30-foot seas on Saturday, the 31st of May, building to 32 feet, holding in the 32-foot range, and we get into Sunday, it continues. So some swell perhaps from that, and then another bit as we get into, this looks better, here we go, with 38-foot seas. We got one more frame, 41-foot seas. Again, it's a week out, but something to keep our eyes on, and it's north of the ice anomaly. The North Pacific, put this into motion. A little bit of a gale forecast, 20-foot seas on Wednesday, the 28th of May. Really 18-foot seas, but sort of pushing towards Hawaii. So maybe some sideband swell. Also notice, and the models have been suggesting this for a while, some sort of a tropical system developing here in the tropical East Pacific. You see it moving pretty much right over Cabo, pretty weak. I mean, that's probably at best a depression by that point. This would be Saturday, the 31st of May. So probably not a whole lot to come from that. I mean, the more, oh, and watch this. What do we got? 20-foot seas, 22-foot seas, 21-foot seas again. There must be some serious wind forecast off Northern California a week from now. To the North Atlantic, we'll just put this into motion. The expectation is not a whole lot's going to be going on here. At best, local wind swell, and you get a little patch of 18-foot seas there. So for next weekend, for surf into Ireland and exposed breaks in Europe. And there we are a week out. The South Atlantic, we'll just put this into motion, see what's going on. Again, that pattern. Once you get south of Africa, things wake up. 31-foot seas building, but look at that. So it's 38-foot seas, but the whole thing is falling south. The fetches aim south. don't really expect anything from that, but this looks much better. 29 to 30 foot seas building to 32 foot seas. This is on Friday, the 30th of May, pushing under South Africa. For sure, swell would be sweeping up the southeast coast of South Africa. Then you see the storm pushing off into the Indian Ocean proper. Is there anything behind that? Probably not. And then to the Indian Ocean. Put this in motion. Not a whole lot going on, but I think the pattern gets a little bit more interesting. So there's that first gale pushing south. Really a storm not doing anything. The next system, but even more interesting right here, starting on Friday, the 30th of May, little gale winds up with, it's hard to tell, nearly 40-foot seas. Let's see, 38-foot seas, 37 feet, push really close to Western Australia and also aimed extremely well into Bali, the Mentawai Islands, and that area. So for sure, swell, you can actually see the swell front already impacting the coast. Another system right behind that with 44-foot seas impacting the islands here. But look at the area of seas in this, covering a broad area. Whoops, we went too far. That's 180 hours out. Certainly seems like significant long period swell would result if this thing develops as forecast for Bali, Western Australia, the usual spots. Wind forecast for California right here in the Hawaiian Islands today, northwest winds. This actually makes it look lighter than it was. It was blowing pretty good, at least in Monterey Bay earlier today. 10 to 15 knots along exposed waters. Trades about 10 to 15 knots for the Hawaiian Islands. As we get into Tuesday, gradient starts building. Low pressure in the Gulf of Alaska, some high pressure off the California coast, low pressure inland. 20-knot northwest winds blowing northern California, central California, that's San Francisco there, Point Conception there. Southern California protected by the Channel Islands. Trades 10 knots for the Hawaiian Islands. So we get into Wednesday, a light wind regime as low pressure approaches the coast. Trades 10 knots for the Hawaiian Islands, 10 to 15 knots for California. Wednesday into Thursday, more low pressure in the Gulf, weak high pressure out here. So what is that? 15, maybe 20 knot northwest winds. Trades 10 to, we'll say 15 knots. Get into Friday, low pressure still in the Gulf. Gradient, 15, 20 knot northwest winds off the California coast. That's probably good for some decent size wind swell. And trades 10 knots for the Hawaiian Islands. Then we get into Saturday. Here comes high pressure building off the coast. Winds build to 30 knots on Saturday. Trades 15 knots for the Hawaiian Islands. So we get into Sunday, 35, 40 knot northwest winds or north winds for Point Conception. Trades 15 building to almost 20 knots. High pressure 1038 millibars building to 1040 as we get deeper into Sunday. And there we go. What's that? 3540. I mean, that's very strong northwest winds for a summertime pressure gradient. There we go. 1042 millibars. Clearly the arrival of the spring La Nina induced high pressure system. Now I'm sort of making more out of it because this happens almost every year, whether it's La Nina or not. But this definitely suggests that we're in for quite a blow and large wind swell. But notice winds not too bad from about Point Reyes on southward. This is on Sunday night into Monday. Let's see where we're at. Take it to 180 hours. Yeah, maybe. I don't know. It's pretty brisk even for Central California. Trades 15 knots for the Hawaiian Islands. So something to keep in your mind. Definitely a wind event as we get about a week out. Precipitation, California right here, North California, Central California, Southern California. The expectation is no rain given all the high pressure. You see rain still pushing into the Pacific Northwest, but we're into Sunday. We're going to go to Monday. There's your impenetrable high pressure, just locking everything down. Wonder if that would be responsible for raising temperatures and making things warm in the Bay Area. Certainly by, I think, Wednesday or Thursday of this week, things are supposed to get a bit on the toasty side. Temperature forecast for the Sierra. This is at the intersection of the Pacific Crest Trail and Tioga Pass Road. That's at about what is that, 8,700 feet right there. And this is a bit old. This last ran on Friday. I mean, there's just a lot of data I got to pull in to make this crunch, and it doesn't always make it all, but you get the general idea. You know, temperatures in the 40 to 45 degree range, something like that, as we get into Monday. And then you see temperatures goes up to 50, 55 degrees, 65 degrees, but nothing any. Now this is at elevation. This is at 8,700 feet. Down in the valley, it will be, well, the valley's at about 3,000 feet, 85 degrees, almost 9. There's 90, maybe like, somewhere right around 90, something like that. So quite warm at lower elevations. Surf spot forecast for the Columbia River area up there, intersection of Oregon and Washington. Surf heights today, 5 feet, fading in the 3 foot range as we get Monday, Tuesday, maybe going up to about 5.5 feet on Thursday. Then as we get into the weekend, things definitely settle down. Winds start picking up, though. You see wind swell 7 feet, and whatever ground swell there is, pretty small. Go look at swell heights, 4 feet at 10 seconds, 4 feet at 9 seconds, 5 feet at 10 seconds. So all just wind swell. Till you get out here, 0.8 feet at 17 seconds, 0.9 feet at 16 seconds, interspersed with 7 foot at 10-second period wind swell next weekend. Ocean Beach, San Francisco. All right, so 4 to 5 foot surf. I assume most of that's all wind swell. Dropping into the 2 to 3 foot range as we get into Wednesday and Thursday. Coming up to 5 feet on Friday. 5 to 6 to 7 to 11 feet there on Monday. This is, of course, now notice local winds not too bad. If anything, out of the south, so an eddy flow, but it's supposed to be nuking up at Point Conception, producing that wind swell. Not Point Conception, I'm sorry, Cape Mendocino. Anyway, swell heights, 1.9 feet, 15 seconds for Monday, and then a bunch of wind swell in the mix, 6 feet at 8 seconds, 5 feet at 10 seconds. More swell, 1.5 feet at 15 to 16 seconds on Wednesday. Thursday, and then the wind swell just takes over 10 feet at 11 seconds. And then as we get Monday, also southern hemi swell, 2.5 feet at 17 seconds. That's pretty decent size southern hemi swell. We go down to Dana Point. That's probably a better indicator, southern hemi swell. So 2 foot surf, 2.5 feet, 2.5 to 3 foot surf, let's say, as we get in Monday and Tuesday, and then slowly trickling down. So we get into the weekend, swell or surf comes up 5 feet or so, and winds nice and light. Let's go look at the swell. 2 feet, 14 seconds for Monday, that's today. Wind swell in the mix. Then 1.9 feet, another southern hemi swell comes in. We'll say 2 feet at 16 seconds on late Tuesday, early Wednesday. That swell eventually trickles out. And then we start getting real swell, 19-second period. This is not the Indian Ocean swell. And that, if it were going to hit, starts somewhere back in here. Of course, the wave models aren't going to see it. I mean, it'd be so small compared to everything else that's going on. But you see swell building to 3 feet at 16 to 17 seconds, so that's minimal, significant class southern hemi swell as we get into Sunday and Monday of next week. Oahu, small surf, 1.5 feet basically until you get into Friday, 3 feet, dropping off, building up to 4.5 feet, and then dropping down from there. Trades all pretty light until you get into Friday, and then trades 15 to 20 knots for a spurt there. Let's go look at actual swell sizes. Nothing expected. A little bit of swell, 2.5 feet. Oh, this is that northwest swell from that gale. 2.5 feet at 11, 12 seconds. And here comes your southern hemi swell. Is that in there? Nope. This is all northwest swell too. So nothing significant really indicated. Tahiti surf heights, 8.5 feet today, fading some as we get into Tuesday, coming back up Wednesday to 10 feet, dropping off, and then pretty small after that. Trades in the 15 knot range the whole way through the week. Swell heights, 5 feet at 14, 15 seconds on Monday, rebuilding to 6 feet at 15 to 16 seconds on Wednesday, then trickling down from there. And our final stop, Bali. Surf heights 5 feet, trickling down as we get into Wednesday and Thursday, rebuilding to 5 feet, trickling down, then up to 5, 6, 7 feet, and then up to 9 feet as we get into a week from now, Monday. Swell heights 4 feet at 12 seconds, dropping off. 3.5 feet roughly at 13 to 14 seconds, then rebuilding, new swell coming in up to 5 feet, 14 seconds, another 5.5 feet at 16 seconds as we get into the weekend. So a nice swell pattern there. So let's go take a look long term. What's going on with the two major weather oscillations that affect the jet stream and the swell pattern long term? That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. So first we're going to talk about the MJO, the Madden-Julian Oscillation. Since we're running a bit late on time here, I'm not going to go into all the educational stuff, but suffice it to say, we're going to first focus on the MJO, the Madden-Julian Oscillation. There are two phases, the active and inactive phase. The active phase is our friend when it moves over the Pacific. It feeds energy into the jet stream, making it stronger, therefore more capable of supporting gale formation. The active phase of the MJO, because it's like a low pressure system, it dampens trade winds. So this chart shows you actual wind speeds across the Pacific. East Pacific here, West Pacific here, that's the equator. That's the date line here. We're just looking at the arrows. Strong trades in the East Pacific, strong trades over the Central Pacific, strong trades over the West Pacific. But it is not the actual speed, it is the difference from normal for this time of year that really makes the difference. So we're looking here, trades, because there's little arrows here, these are the anomalies, that means they're blowing stronger out of the east than usual. That would be probably supportive of the inactive phase of the MJO. Over the Central Pacific, trade's pretty much normal, and the West Pacific, trade's pretty much normal. So maybe inactive phase over the East Pacific. What's the forecast suggest? Well, this chart is 850 millibar zonal wind anomalies. Are the trade winds stronger or weaker than normal? The blues, stronger than normal trades. The oranges and reds, weaker than normal trades. This is over the entire planet right there. That's 180 west, so that's the date line. The far west Pacific starts right here at 135 east. So today, a little bit of westerly anomalies, probably indicative of the active phase of the MJO over the maritime continent. But for the most part, trades, stronger than normal trades in control of the Pacific. This is 120 west, so that's California, and 80 west is about here. That would be where Ecuador is. This is just 5 degrees north and south of the equator. All right, so basically this suggests inactive phase probably in control. But notice each day we go out, by the end of May, westerly anomalies building halfway across the West Pacific. And as we get towards the first week in June, westerly anomalies theoretically taking over the bulk of the West Pacific. This would probably be the real end of La Nina and the beginning of an ENSO neutral pattern. We'll see how, let's go look at some other models, see what they say. Outgoing long wave radiation forecast, just fancy words for cloud cover. If you have more cloud cover than normal, that suggests low pressure, warm moist air lifting up into the atmosphere, condensing. So let's look at this chart. South America, Central America, New Guinea there, the equator right there, 180, that's the date line right there. So this is, the blues are cloudier than normal skies, the oranges, yellows, drier than normal skies. So this would be the inactive phase of the MJO over the East Pacific. No wonder the trades are stronger than normal there, because that's the inactive phase is like high pressure, a generalized high pressure. The active phase here is a generalized low pressure. That would be weaker than normal trades. This is a statistic model. Notice 5 days out, 10 days out, 15 days out suggests the active phase of the MJO, not particularly strong, but making it into the West Pacific. The GFS model, basically showing the exact same pattern. That's good news, and we can see the last frame of the two models here, looking very similar. Maybe the GEFS a little bit stronger than the statistic model, but not by much. So this sort of looks like over the next 2 weeks, active phase building into the West Pacific. That would be feeding energy into the jet stream and making for, theoretically, a more active storm track in the southern Hemi. Phase diagrams for the same two models, they show where the active phase is. The active phase goes around the planet from the Indian Ocean to the maritime continent, to the West Pacific to the East Pacific. This is on the equator. under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is. If it's anywhere near the circle, it's considered pretty weak or very weak. So a very weak active phase today over the maritime continent, forecast by 1, 2, 3 different members to be right smack in the middle of the West Pacific 2 weeks from now and weak. The GFS model, basically showing the exact same thing. It looks like the active phase somewhere here in the west, somewhere west to east Pacific, and very weak. So pretty good correlation between the two models. Upper level model, again, this goes out 40 days. Areas favorable for precipitation. This shows greens, wetter than normal air, active phase, the MJO over the maritime continent. There's South America, Central America. 0 is the equator, the date line roughly there. This showing the same sort of thing, active phase working its way across the West Pacific to the Central Pacific by about mid-June, then out of the picture with the inactive phase moving into the West Pacific for the latter part of June into early July. So again, June looking good on the models. The CFS model going out 1 month past performance, the top, the forecast down here. Blues, easterly anomalies, reds, westerly anomalies. Date line runs right up the middle of the chart. So you see, and this actually has the active, the MJO. Dotted contour, inactive. There's a weak active. But I mean, the MJO basically exceedingly weak. Right now we're in the inactive phase, according to this, pushing over the date line for the next week and a half, something like that. But after that, active phase setting up, west anomalies, taking over not only to the date line, but west of there. So this says somewhere after about June 5th, let's say, things are going to get kind of interesting in the Pacific, at least according to this model. One more to go. This is the CFS model going out 3 months. Same sort of drill that it's been telling us for months now. You can see a date line right here. Past performance on the bottom, forecast up at the top. Blues, easterly anomalies, that'd be roughly the inactive phase, the MJO. And then yellows, westerly anomalies, active phase, or La Nina, and maybe not La Nina. All right, but anyway, you see a week from now, westerly anomalies building in, taking over, and forecast holding for the foreseeable future. The death for sure of La Nina. We'll overlay the MJO. You see back here in February and March, 1, 2, 3, 1, 2, 3, stronger active phases of the MJO. Now the MJO as weak as it can be and staying basically like that until we at least get into the later part of July. Let's overlay the low pass filter. This is really the teller here. This is your La Nina El Nino indicator. The dotted contours, the La Nina indicator, high pressure bias. We had 3 contours. Third contour is dead. Second contour is to die about a week and a half from now. And then the final contour already now starting to ease off to the east. The low pressure bias over the maritime continent, the West Pacific starts about 135 east, so right on the hairy edge of that. Somewhere as we get into mid-June, the low pressure bias starts moving into the Pacific, dragging westerly anomalies with it. This is what we're waiting for. The model originally said the arrival of these westerly anomalies, I thought it was March 24th. Now we're 2.5 months later and it still hasn't fully happened. So, you know, the models aren't getting it quite right, but they are suggesting it's going to happen. And I think they're just a little bit aggressive on how quickly La Nina is fading in the atmosphere. Now, this is not indicating El Nino. Let's not make that leap of faith. This is just moving us towards ENSO neutral, which is where we want to be. And now on to the ENSO part of the discussion. We're going to start by looking at subsurface water temperature profile. All right, West Pacific here, East Pacific here. This data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. These are the anchor lines, sensors on the anchor lines. They collect data, use a model to fill in the gaps, and you get to see where the warm and cooler waters are in the Pacific. If your trades are stronger than normal, all your warm water builds up in the West Pacific. If your trades are in collapse and you're in El Nino, or if your trades are reversed, then all this warm water here starts building up over in the East Pacific. So we look at where these different isotherms are and are they moving and what's going on. The 29-degree isotherm at about 173 east, about exactly where it was last week. The 28-degree isotherm at 63 west, exactly where it was last week. The 24-degree isotherm at 25 meters of depth and holding. So everything looks pretty much like it did last week. But it is the anomalies, difference from normal for this time of year, make a difference. 1 degree anomalies in the west, 1 degree in the east. Literally no cold water indicated. And this one thing here of -1 degree anomalies, not changing one way or the other, really making no difference. This pretty much looks exactly like it did a week ago. A high-res version of that chart, including satellite data, suggests, well, lo and behold, look at this. Looks like a Kelvin wave, warm water, lots of warm water. What's that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 to 4 degree anomalies here in the far West Pacific. This looks like it's literally spilling out of the maritime continent into the Pacific Ocean, getting driven across. Leading edge here at about, well, that one finger there is at 120 west, and this whole thing has been steadily building off to the east, suggesting trades or westerly anomalies, at least in the West Pacific, has created a Kelvin wave and it's pushing across the Pacific. That is a good sign suggesting the demise of La Nina. We haven't had a legitimate Kelvin wave, warm water up downwelling Kelvin wave in 2 years since the last El Nino. Here's the sea height data used to amplify the previous chart. This is not temperatures. This is the sphere of the ocean higher or lower than normal? Of course, lower than normal anomalies suggest, like these -15s up here and down here, suggest cold water at depth. The positive anomalies, 0 to 0.5 to 10 here and here, suggest warmer than normal water at depth there. That looks like your Kelvin wave right there, making it to about 165 west, and dead neutral, pretty much anomalies going the whole way across the Pacific and a little bit higher than anomalies here over in the East Pacific. Very much looking like ENSO neutral. Then this chart puts it all together. East Pacific here, West Pacific here, the reds, warmer than normal temperatures, the blues, colder than normal temperatures. Here's your upwelling Kelvin waves from La Nina, and then we got to about March and it all just shut down. Here is our Kelvin wave making it across to about 137 west as of now, and then warmer than normal temperatures, mainly just from lack of trades here in the East Pacific. So this looking like ENSO neutral. At least we don't have any of that blue stuff, colder than normal temperatures down here. Warming temperatures eventually help support evaporation, help building clouds, create lifting air, and that lowers pressure across the equatorial Pacific, and then that's exactly what we want to feed the jet stream as we get into the coming fall months. Then we go to the ocean surface, sea surface temperature anomalies, South America, Central America, New Guinea, equator right there, dateline right there. Temperatures warmer than normal off of Ecuador, a couple of pockets of cooling right here south of Mexico. And then as you get further out here, pretty much neutral, a couple little pockets of cooling. The official El Nino monitoring region from 120 west, 5 degrees north and south of the equator out to 170 west, so right here. Kind of eyeballing that, I'd say we're neutral or just slightly below neutral. Let's go look at an alternative chart. This one's a little bit different. The previous chart was based on a lot of history and a whole bunch of other stuff, and they tried to correct for a warming planet. This just goes, whatever the average temperature on all the oceans across the planet right now, that's considered normal. Any deviation from that is negative or positive is considered abnormal. So based on that, this suggests there's a much broader area of cooler water here from 160 east, the whole way almost off to Ecuador, and the only warming is really off of Ecuador and in the far West Pacific. Now, the deal is, I don't know how much history is behind this chart. I mean, I think NOAA takes it into consideration, but I don't know that it is considered the ground truth. It's in I'm not going to say it's an alternate reality. It's just a different perspective, one to keep in mind. Sea surface temperature anomaly trend for the past 7 days. Well, you can see it right here on the equator. That's all that matters. A little bit of warming in the west, kind of neutral the whole way across. Maybe just the faintest hint of cooling right here south of Mexico, and then pretty much neutral here. So ocean, not really warming, certainly not cooling, pretty much holding steady state in the area that matters, 5 degrees north and south of the equator in the Pacific. That's what drives everything around the planet. Sea surface temperature trend in the official El Nino monitoring, this column right here. For the week of May 21st, 0.2 of a degree below normal, pretty much neutral. The week before, 1/10 of a degree below normal. Week before that, 1/10 above. You sort of see the trend. Just hovering right at neutral, I'd say, since the end of February and on. Not getting warmer, not getting cooler. I think we're really waiting for westerly anomalies to start building over the West Pacific, and then we might see some nudges in this data. So what does the atmosphere think is going on? We look at the Southern Oscillation Index, difference in pressure between Darwin, roughly in the Indian Ocean, Tahiti in the Pacific. When pressure is lower in the Pacific, and that's what we want, lower pressure in the Pacific is a sign of at least the active phase of the MJO, if not a building El Nino. Today's value, very positive, 23.46. Positive, not in a good way. Suggests building high pressure, and it's been 1, 2, just 4 days. Looking prior to that, it was pretty much negative. So this sort of looks like we're going, and the active and inactive phase, it'd take about 4 or 5 weeks to make their way across the Pacific. So this looks like active phase was in the West Pacific. Well, Tahiti really is in the Central Pacific. Now it looks like the inactive phase is building there, which is pretty much what we saw in the models too. 30-day average, minus 0.51. Where were we a month ago? 5.47. So again, this looks like we were inactive, going to active. Now we're starting to come in out of it, maybe the inactive phase building over the Central to East Pacific. 90-day average, plus 4.31. Where were we a month ago? 7.28. So, still biased weekly towards La Nina. Let's go look at a graph, see if that tells us something. The 30-day running average for the Southern Oscillation Index, you see here we are, boom, this is the active phase of the MJO, double dip active phase. Below this line here, the white is neutral. When you're down in here, that's El Nino territory. When you're up here, you're in La Nina territory. Here was our La Nina, just barely this, from December, March, May. Now we're heading down. Are we going to El Nino? No, I think that, we just saw the inactive phase is starting to build, so this will creep back up and probably move into the neutral territory here for a little bit until westerly anomalies take over. Sea surface temperature anomaly forecast for the Nino 3.4 region, the official El Nino monitoring region from the CFS version 2 model. All right, so where are we? We're in May. Actuals right around here. Dead neutral. Forecast going up to maybe 1/10 of a degree as we get into August. Then, according to this, dipping down to maybe 1/4 of a degree below normal for the fall, and then back to about neutral in January. All this is neutral. Half a degree, from half a degree above to half a degree below is considered just normal variation. You're not in La Nina till you're, down in here, and you're not in El Nino till you're up in here. So all this looks neutral. Let's go see what the consensus forecast says. It just updated. Model projections of ENSO from May 2025. 0 is neutral. The green line, let's see if we can get that guy to light up. Statistical average, well, there's your half a degree above, half degree above. So statistical model says ENSO neutral. If I can get it, I don't know that I'm going to get there. I got it. So there we go. The dynamic average, about the same thing. Let's go look at the data here. Zoom right in. These are all the dynamic models. They're the average of all of them. You can see neutral, down to 0.3 of a degree as we get into October and November, and then back to neutral. The statistic models, 25, 27.3, in about the same time frame. Average it all together, quarter of a degree below neutral, and then returning from there as we get into the fall and winter. All right, so for right now, things looking pretty good in the southern Hemi. Jetstream, not horrible, not great, but supportive of gale development and one, if not two gales forecast over the next week. Swell from previous gales radiating northbound into California. I think, some degree of swell for the next couple of days, but that's steadily declining. Then we get into next weekend, larger southern Hemi swell, though significant wind event forecast at the same time. Over the Cape Mendocino region, lots of wind swell in the water. We'll have to see how that plays out. Hopefully the models are overhyping it and that will die off. The other thing, Indian Ocean swell. Well, Wednesday, Thursday, Friday, Saturday. We'll see if it pops up on the buoys. But I'd say the odds are like, at best, 10% of us seeing anything. But just a fun little science game anyway. Beyond that, ENSO. Right now, still looks like ENSO neutral the whole way through fall and winter. That's good in that we're theoretically not going to be in La Nina. We won't be in El Nino either, but I went back and looked at the record going back 20, 30 years, and I haven't found a single year that was what I would consider just dead neutral. So this, I think, is a good thing. Way better than being in La Nina. We'll have to see how it plays out. They can cut both ways. If it's too neutral and you get no momentum in the atmosphere, then the jet stream sort of doesn't know what it wants to do. You don't get good forcing of storms. So it could be a mixed bag this coming fall and winter. We just don't know. Neutral does not necessarily mean normal, but we'll have to see how that plays out. Anyway, for now, looks like there is surf in the water right now, more on the way. That's good news. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, click the Stormsurf icon down in the lower right-hand corner of the screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. We always appreciate it when you do make a contribution. Other than that, we are done for this week. We will see you again next week. Same time, same channel. Thanks so much for watching.